Welcome to this SOFiSTiK tutorial presenting the life cycle assessment task, which was introduced in SOFiSTiK version 2025. We will use this small model to demonstrate how the life cycle assessment is done. This example building consists of 2 stories. For the slab, we used concrete C3545, and for the columns and walls C2530. Additionally, there is a steel frame on the side of the building. We defined a design element representing this slender wall to be able to design it with the column Design Assistant. Since we want to do some design steps later on, we have defined 2 load cases, dead weight and a live load. We will start with inserting the life cycle assessment task in our project. In principle, the task can be inserted in every SOFiSTiK FEA model. Then it can be used to calculate the global warming potential based on the materials and masses in the project. Let's open the task. To make things easier for you right from the start, we'll first ask if you'd like to use data from the ÖkoBaudat. If you say yes, just pick the annex you need, and we'll automatically fill in all relevant materials with matching EPDs. Super quick and convenient, and you can change them later on. Of course, if you prefer to add your own EPDs manually, just select Others and enter them yourself. Now the task lists all materials in the project. The mostly used standard materials, like concrete or reinforcement steel, are matched with corresponding datasets from the German database ÖkoBaudat. Here you can see the name of the match dataset. For the steel, no material is matched, because the GWP values more depend on the member form than on the steel grade. Therefore, corresponding datasets cannot be selected in advance without knowing the details of the structure. One option is to manually enter here a value from an EPD. If you need to adjust the unit to your entered global warming potential, that's no problem either. Simply choose a unit from the drop-down menu. But if you're using ÖkoBaudat, you don't necessarily want to look up the value yourself and then transfer it. Select the material you want to match and press Select EPD from ÖkoBaudat. A new window opens with the ÖkoBaudat datasets. The tab with the annex A2 EPDs is in front, since this is the annex we selected while opening the task. To search a specific EPD, the search field can be used. We search for steel. Now the EPD titles are filtered for the word steel. There are still a lot of entries, so maybe we refine our search a little bit. Let's try structural steel. Here it is. We will use the EPD for sections and merchant bars. The global warming potential values for the different life cycle phases are automatically added. Speaking about life cycle phases, here in the task we have the phases A1 to A3, which represent the product stage, and C3, which is the end-of-life waste processing. There's also the possibility to activate phase D, if you plan to consider the recycling potential. For now, we have limited the task to these phases, which have been selected based on the recommendations from the German Sustainable Building Council and on availability in the datasets. Now that the GWP definition is finished, we can take a look at the assessment in the next step. In this second part of our tutorial, we want to take a closer look at the assessment report and the calculation options. These are the available calculation options. We will take a look at the report first, and then we will put some of these options on and off to show you how the report is influenced. So first step is to calculate. Then we open the report. Here is a summary of the materials with their GWP properties stored in the database. The lifecycle assessment report starts here with the design elements. If you remember, we have one design element in the model for the slender wall. Then there are 3 tables: the group assessment, secondary group assessment, and the material assessment. The tables all have a similar structure. See, for example, the material table. It lists all the different materials, then the total volume or total mass of the material. Then the GWP separated per phase and the total sum for this material. And down here is the total sum for all materials. We see that our total sum at the moment is 3.29 CO2 equivalent. So now let's go back to the task. The first calculation options are for influencing which element types are taken into account in the calculation. For example, if we exclude the beam elements and then calculate again, the total sum changes accordingly. With the design elements, it's a special case. Switching off the design elements does not change the total number, but excludes the design element table from the calculation. This is because design elements are integrating results and masses. Therefore, they have no influence on the total sum of masses and consequently on the GWP. The total sum does not change, but the table for the design elements is now gone. The second part here defines the kind of evaluation that should be done. First, we will start with the material evaluation. Now we have only the materials table. Then let's activate the group assessment. We use the primary groups to group the members in our model per type and story. Let me show you in the viewer. First, we switch all groups off. You can see that 10 groups up the columns, 11 the walls, 12 the slab, 13 the steel parts, 20 the second story columns, and 22 the second story slab. While an element can only be sorted to one primary group, it can be sorted to several secondary groups. Now the secondary groups table should appear. We use the secondary groups in this example to represent the cost groups according to DIN 276. Let's take a look again to show you how the elements are sorted. Here are the defined cost groups for walls, columns, and floors. And they are used here in the assessment table. There is no total sum because elements can belong to several secondary groups. Then we have 2 options for concrete structures to consider the reinforcement or the tendons. In our model there are no tendons, but we have reinforcement. Since we haven't calculated the design tasks, the assessment at the moment considers the predefined reinforcement from the cross sections or the design parameter task. So if we switch this off, our total sum should change. When we reload the report, we see that the total sum has decreased. When you, for example, want to define your own lifecycle assessment tables with the result viewer later on, you can switch the predefined output off, so you don't have double information in your report. We are going to calculate. Then all the tables disappear. This is it for the calculation options. Up next, we will take a closer look at the export to Excel. Now, let's take a closer look at the Excel export. The export is intended for use cases where 2 or more model variants should be compared regarding their global impact. The results can be stored in an Excel file before changes in the model are made. First, we have to activate the export. We use the suggested file name. We could also open an existing file here. This here is for the predefined Excel templates, which we discuss later on. We now make a quick test export. The exported Excel file is saved in the project folder. We could open the folder here. But we will use the shortcut directly to the file in the task context menu. The exported file starts with an overview. For each variant and phase, the total mass, total volume, and total GWP is listed. Additionally, the 4 tables printed in the report are exported as well. The Excel tables can then be used for individual evaluation and diagrams. A faster way is to use predefined templates, which already include diagrams, etc. We will now export again using a template. Click here for selecting the template. There are 3 predefined SOFiSTiK templates available, but one could use customized templates as well. We will select the English template since our selected SSD language is English. The template file is renamed and copied to the file path defined under File. Therefore, if a file with the same name already exists, the task gives a warning that the file and all previously exported results will be overwritten. In our case, that's okay. We now store lifecycle assessment results of a first variant. We name it Reinforcement Before Design. These are the results based on the predefined reinforcement without using any design tasks. Let us take a look at the exported file. The exported detailed tables for the variants stay the same. The variant overview is also still exported. The dashboard is an additional table defined in the template. It gives a nicer formatted overview of the different variants, including an automatically generated diagram. Now we design the columns using the Column Design Assistant. The Design Assistant groups the columns in design groups. Here we can see that 2 design groups have been defined. They are basically additional secondary groups. So they will also appear in the lifecycle assessment based on secondary groups. Okay, so now we do the ULS design for the area elements. And then we have a new design case with higher reinforcement, since the predefined reinforcement was rather low. Now we can do a lifecycle assessment for this variant. It is important to change the variant number and the variant name, or the old results would be overwritten. Let's take a look at the Excel file. There are the detailed tables for the second variant. And in the dashboard, both variants are now displayed. As expected, has the model after design a higher GWP due to the higher reinforcement. The diagram in our SOFiSTiK template is defined to color the different variants in relation to each other. The variant with the highest GWP is displayed in red and with the lowest in green. Variants in between would be yellow. In this part of our tutorial, we will create a lifecycle assessment table with the result viewer. We first insert the result viewer task. We use the table assistant, which gives us predefined tables for the lifecycle assessment. Here is a table for the secondary groups. It gives us all the defined secondary groups, including the designation, the phases, the volume, the mass, and the total GWP per phase and secondary group. We now calculate the task. In the report, there's now our customized table with the secondary group evaluation. With these steps completed, you now have a clear framework for performing lifecycle assessment in SOFiSTiK.